All right, next we have annuity, which is simply a series of payments made at an equal interval. Example, well, I don't think annuity is just something that you make in an equal interval of time. It's something that you're paying off, something that's going to have some finality to it. If you're making car payments, the car payment's an annuity. If you're making a house payment, it's an annuity. If you are putting money in intervals of time, so you're saving money, maybe into some type of retirement account, that's an annuity. So there's two big wretched formulas for these annuities. The present value of an annuity. So here's your two different formulas, present value and future value. Present value is P, future value is F. Now we got these variables in here. P is the dollars per payment. N is the number of payments per year. R is the interest rate as a decimal. Not as a percent, but as a decimal. And then P sub n is the present value. F sub n is the future value. I think that covers all the variables. So what's the difference between a present value and a future value? Present value would be something like you took out a loan. You borrowed $100,000 to buy a house. The present value of that money is $100,000. Present value is oftentimes associated with some type of a loan. Future value is often associated with you investing some type of money. You save $1,000 a year, put it into some type of account, and you're hoping that in the future this money is going to grow. So this is usually some type of investment. Let's do some examples. A monthly mortgage payment consists of an amount paid towards the principal and the interest on the loan. Principal means money that you're paying back on the loan. Interest is money that you're paying extra because the bank is making money off of you borrowing money. Lots of words. The Waltons have taken a 30-year mortgage for $100,000 with an interest rate of 9% on their new home. We got to figure out which formula that we're going to use here. This is going to be a present value problem because the money today is worth $100,000. That's the present value. Let's write that down. Present value is $100,000. We need to know what P is, what R is, what N is, and what T is. T is the time in years. It's a 30-year mortgage. N is the number of payments per year. It's a monthly mortgage, it says in the first sentence. That means you pay it once a month. There are 12 months in a year. Except for a leap year. On a leap year, there's 12 months. R is the interest rate as a decimal. It's 9%. As a decimal, that's 0.09. P is the payment per month. We don't know what that is. That's what we're trying to figure out. So let's plug these numbers in as best we can. P sub n is 100,000. P, we don't know. R, 0.09. N is 12. And this is to the negative 12 times 30. N is 12, T is 30. It's divided by R, which in turn is divided by N. Let's simplify this as best we can. Some things that we can obviously simplify. 12 times 30 we can simplify. 0.09 divided by 12 we can simplify. 0.09 divided by 12 we can simplify. Using a calculator. 0.09 divided by 12 is 0.0075. If you add 1 to that, you get 1.0075. Not using a calculator, 12 times 30 is 360. That's a negative 360. And then once again, 0.09 divided by 12 is 0.0075. Our goal is to get p by itself. Usually I take it in the bathroom and it gets by itself pretty easily. That was hilarious. Trying to get p by itself, right now we're multiplying it by this fraction. To get rid of the fraction, if we simply multiply both sides by the reciprocal, we can get rid of it. So we're going to multiply both sides by 0.0075 over 1 minus 1.0075 to the negative 360. We're going to multiply it over here as well, and I don't have much room to write it. You have even less room. And this is getting embarrassing. You get the idea. I'm not going to write it on both sides because I don't have enough room. Mathematically speaking, you don't have to write it. I was just trying to show you. So, when you reciprocate this, when you multiply a whole number, 100,000, times a fraction, you multiply it times the top. So the top, when it's reciprocated, is 0.0075. 0.0075 times 10,000 is 750. Denominator stays the same. This is as simple as we can get this without using a calculator and getting around an answer. If you put this in your calculator, you need to do that right now. Because if you put this in wrong, you need to figure out where I am so I can help you put it in correctly. This is going to be $804.62. If you have the power of pause the video so make sure you can put that in your calculator correctly. So the question was, what will the monthly payment for the principal and interest be? The monthly payment, $804.62. That's pretty good, right? You need $100,000 to live in this house, which you don't have. So the bank says, tell you what, we will take $804.62, just give that to us every month. And in 30 years, the house is all yours. Well, here's where Part B comes in. Part B says, how much will the Waltons pay in interest over the life of the loan? Well, the first thing we got to figure out is, what is their total payment? How much money have they paid out? Simply take the number of payments times the dollar per payment. The number of payments should be pretty easy. They're paying for 30 years, and they're making 12 payments each year. They're making 360 payments. Dollars per pay. We just figured out every month they're paying $804.62. If you multiply those using a calculator, you'll get that their $100,000 house only cost them $289,663.20. In case that doesn't resonate with you, let me put it into simpler terms. It's worth $100,000, and you paid over $189,000 more for it. The bank's not nearly as nice as you would think. So the question here was, what is the interest? That's easy to figure out. The interest is going to be the difference between what the house was worth and how much you paid. So in this case, that's going to be the total payment minus the principal. Principal, once again, is what the house is worth. well, not necessarily what it's worth. It's how much money you borrowed. You borrowed $100,000. That's 289,663.20 minus 100,000. Without using a calculator, that is $189,663.20. The house cost you $100,000. The loan cost you $189,000. If that doesn't shock you, the following will. The loans that you take out for your college are very similar to this. So if you think you're going to pay $40,000 for college by borrowing it, it's more likely you're going to be paying $120,000 for that education if you have to take out loans and pay them back later. Sad but true. Don't take out loans for college. Please. Next problem. When Jim Bob started his first job after he finished college, he opened an individual retirement account, which is known as an IRA. He plans to contribute $2,500 per year for 38 years until he's 62. He hopes to earn an average of 8% over the 38-year period. Question A. If Jim Bob contributes to his IRA at the rate at which he plans, how much will be in his account when he's 62 years old? It's asking you, what is the future value going to be? So we have to use the future value formula. What is the money going to be worth in the future? The dollars per payment, which is what P is, he's paying $2,500 every payment. The interest rate he's hoping to get is 8%, which is 0.08. The number of years he's going to do this is, N is the number of times he's paying a year. It says he's paying $2,500 per year, so we can only assume he's making one payment a year of $2,500. The number of years he's doing it, which is T, is 38. Take those numbers and we're going to plug them in. F sub n, we don't know what that is. The dollars per payment is $2,500. Interest rate is 0.08. Number of payments a year is 1. And then our exponent is 1 times 38. And divide that by 0.08 divided by 1. Without a calculator, we can get this a lot simpler here. 0.08 divided by 1 is 0.08. 1 plus 0.08 is 1.08. 1 times 38 is 38. So we got 1.08 to the 38 minus 1 divided by 0.08 divided by 1 is 0.08. We can do a little more simplifying here, not much. 2,500 times the fraction. This 0.08, we can divide it into this numerator or we can divide it into 2,500. If we divide it into 2,500, it's going to make this problem a little bit nicer to look at. 2,500 divided by 0.08 is 31,250. This is as simple as we can get it without rounding. If you continue to put this into your calculator, you're going to get a handsome sum of $550,789.86. That's how much his account would be worth in 38 years. That's the answer to Part A. Part B says, how much interest will be earned on the account? Well, to figure that out, we got to first figure out how much money has he paid out. What is his total payment? Simply take the number of payments times the dollars per payment. He made one payment a year for 38 years. It's 38 payments. He paid out $2,500 each time. 38 times 2,500 using a calculator is $95,000. That's how much money he saved for retirement. It's a lot of money he put in. But as we saw, it was worth $550,000 when he was done. more than 5 times what he put in was what it was worth. So how much interest did he earn? Interest taketh away, and interest giveth. In this case, we take the total payment. It's not true. In this case, we take the future value minus the total payment. The future value we just figured out in Part A. This money in the future is worth $550,789.86. The total payment is $95,000. Subtracting those, the interest that Jim Bob earned, $455,789.86. Interest can be your best friend or your worst enemy.